Hi everyone, in today's video I want to talk about the super keyword within the Java programming language. The super keyword is one of those keywords that is sometimes a little difficult to understand, and you already have to use it in situations where you have to deal with inheritance and polymorphism, and it's not always clear how it works. In today's video I want to clear that up a little bit. To understand the super keyword, it's also important to understand the this keyword. So I'm going to spend a little bit of time on this, with most of the time on super. And what I want to do is talk about super within three different contexts, with fields, with methods, and then with constructors. So rather than explaining theoretically what the super keyword does, I think it's going to be a lot easier if I look at some code with you guys. So let's get to it and get IntelliJ up. All right, in IntelliJ, I'm going to go ahead and make a new project. We'll just call it cats. You'll understand why in a second. All right, now we have our main method. And why did we call the project cats? Well, what we're going to do is we're going to demonstrate how to use the super keyword, but in order to do that, first you need to establish inheritance. Typically also within the context of the super keyword, you're also going to be dealing with polymorphism, but first we're just going to talk about making an inheritance structure. So we're going to make a class called cat. And then I'm going to make another class called big cat. And big cat is going to inherit from cat by using the extends keyword. If you're not already familiar with inheritance, I'd highly recommend you check out one of my previous videos on that, or just a general tutorial on how inheritance works in Java. So now that we are extending cat from our big cat class, big cat has everything that cat has. And if you recall, cat implicitly is inheriting also from object, so cat has everything that object does. So let's go ahead and make a big cat. All right, like normal, what we do is we have the name of the type, we have the variable name, and then we have what we're setting it equal to, which is a new instance of big cat, which this case is calling the big cat constructor. And in our case, this is the default constructor because our big cat class doesn't define an explicit constructor within here. So what I want to do to make sure that my object is getting constructed correctly is I'm going to go ahead and just create a public field called weight. So my big cat is big. Let's say that it is 40 pounds. But my regular cat is only 10 pounds. If I can type that. All right, so now if I go to bigcat.weight, and I print that out, this should be printing out the weight of the big cat, which is going to be 40 pounds. And as we expected, we get 40 pounds here. Now, let's say I comment this out. That's a nice little trick within IntelliJ. If you hover over a line and you do Control/, then it automatically comments out the current line you're on. You'll notice that the code still compiles, and if I run it this time, I'm going to get the parent cat weight. And that time we get 10. Okay, so what this is doing is, this is demonstrating inheritance again. So we have a public field called weight that our cat class has. Our big cat has a weight here, but we're commenting out this line of code, so it's not getting executed. So now we use the parent class weight, and then that's what is printed out when we ask for the big cat's weight. All right, so let's make this a little more interesting. So instead of relying on the weight within our parent, let's go ahead and figure out the weight of the big cat based on the parent. So let's go ahead and access our parent weight. The way we do that is with the super keyword. You'll notice if I just type super here, it highlights this orange color, just like public class and extends. That means that it's a keyword within the Java language. And what the super keyword is pointing to is a reference to the parent class that our subclass is inheriting from. So just like any other reference, I can now use the dot operator, and now I have access to everything in the parent class. So this time, let's go ahead and get the weight of our parent cat class. So now super.weight, now this should be equal to 10. We can see it right here. Let's go ahead and say that our big cat is 30 pounds more than a regular cat. Excellent. So now we're back to 40 pounds here. And the great thing about using the super keyword is now let's say that I want my regular cat to have a weight of 20 pounds. Then now our big cat should have a weight of 50 pounds. And that right there is an example of how the super keyword with fields can be quite useful because you can infer data in your subclasses with data from your superclass. So this is an example of polymorphism because we are changing behavior in subclasses. We are using the many forms concept within polymorphism. We are using the weight field within the big cat. And in this case, rather than just having a defined weight that we give our big cat, we are specifically determining the weight based off of the weight of our regular cat. All right, so now that we've demonstrated fields, let's go ahead and demonstrate this with methods. Delete this. And let's go ahead and make a public method that says make noise. And our regular cat is just going to say meow. And our big cat is going to say meow. Because big cats say meow much louder than little cats, right? So let's go ahead and do big cat dot make noise, and we'll verify this is doing what we think. Very good. As expected, we are calling the make noise method within the big cat class because we are overriding the implementation of the cat class's make noise method. Let's go ahead and make this a little more interesting. Let's go ahead and modify this code a little bit. So if I wanted to, if I comment out this line of code, I could also go in and do super.makeNoise. And if I run this code, we'll see that now we're only calling the cat class make noise method, which actually what we're doing is we are calling the big cat make noise method, which then goes back and calls the regular cat make noise method via this super keyword here. Now that implementation isn't very useful because why are we even overriding the method when we just call super right away? So typically what you might see is you'll call a base class implementation like this, and then you'll add your specific processing afterward. So in this case, now we're gonna call both. All right, now here you can see that we are calling the base class implementation and then we are calling the subclass implementation. The order in which we do these doesn't matter. That's another little hotkey I just did in IntelliJ. Shift Control up or down arrow allows you to shift the position of a line of code. Now, one thing you'll notice, and we'll notice this when we get into the constructor section, the placement of when you call super within constructors is important versus in methods. You can do it wherever you want. And now here we call the subclass implementation first and then the superclass implementation. Another thing I want to mention is you can use the super keyword when you're calling methods wherever you want, really. So let's say I make another method called do something, and what I can do in here is I can also call super.makeNoise. I don't have to call it just within the make noise method that I'm overriding within my subclass. So now I'm going to go ahead and say do something, and then I'm going to say make noise. As expected, when we call do something, we are using the make noise method of the base class here. And then when we call the make noise method, we are going back to the subclass implementation. One thing I'd recommend is folks don't do this sort of thing very often where you're calling the super method of a completely unrelated method within method X, like do something here, and then you've got the overridden method here. Typically what you'll do is you'll call the superclass implementation within the subclass implementation, but you don't always have to. All right, so now that we've looked at fields and methods, now there's a special type of method, which is constructors, that I want to talk about next here. I'll go ahead and clear this out. And now we're going to go ahead and define a constructor other than our default one. So to do that, I'll go ahead and make it public. we'll call it big cat, and rather than having a return type, the return type of a constructor is implied. So you don't need to include the return type here. All you have to include is the name of the class and then parentheses including the parameters that you would want to pass into the constructor when you call it. So what I'll do in this case is I'm going to say in big cat constructor, and then I'll copy this, and then we'll have a similar version for our cat constructor. All right, so now all we have to do is create an instance of our object, and that is going to call the constructors that we just made. Interesting. So first it calls the cat constructor, and then it calls the big cat constructor. So let's dig into what that means for a second here. So if you look at the big cat constructor, I don't see anywhere where we're calling the cat constructor explicitly, but Java actually is doing that for us. So Java is doing this. And I'll go ahead and demonstrate that here in a second, and I'll explain what that means. So I run that, I'll get the same result. All right, so as you can see in the output, we get the same result when in our big cat constructor, we use this syntax, which kind of like how we talked about how a constructor is a special type of method. The way that you invoke a constructor for a superclass is use the super keyword, and then you add any arguments that you would need to in order to call the constructor. To demonstrate how that's similar to the this keyword, what I'm going to do is I'm going to go ahead and create another constructor. This time we'll pass in a weight, and I'm going to go ahead and make a field. Let's give it a default value of 10. And I'm going to say this dot weight equals weight. So like we've normally done in the past when we are using the this keyword, that is referring to the current object. If I were to make this public and I were to make cat have a weight of 10, gotta give it a type here. And I'm gonna go ahead and give that a type as well. And let's go back to using the parent class's weight and then adding, well, let's go ahead and add 20 pounds this time. We don't want our big cat to be too big. So now what we're doing is when we use this constructor, what we're actually doing is we are setting the weight of the big cat to the weight that we pass in. So let's say I want my big cat to have a weight of 50 pounds. And whoops, I forgot to print out the weight. All right, let's try that again. All right, there we go. So interestingly, if I go to big cat, so in this constructor, I'm also implicitly calling the cat constructor. We can see that here. And then I'm setting the weight to 50 as we expect, even though originally I would have expected it to be 30. Now just to prove that I'm not changing the weight of the cat class, let's go ahead and create a method called getBaseCatWeight. And in this case, I'm just going to go ahead and return super.weight. If I can spell weight correctly. All right, that's better. So now if I do big cat dot get base cat weight, this is an example of the this keyword within action as it interacts with super. So when I go to my big cat, I'm using the big cat constructor with the weight argument. I set the weight using the this keyword, so I'm not influencing the super cat at all. And you can see that when I look for the weight for the parent instance, and I get the same thing that I had in my cat class where it's a value of 10. And one other thing that you can do with this keyword that I want to touch on really quickly is if you want to call another constructor within your current constructor, I'll go ahead and delete this for a second. You can do that with this keyword. So what this line of code is doing is it's calling the constructor with the set of parameters specified here, which is none. So you can see that it actually hits right here. So let's go ahead and run this code and see what this does. As expected, the first thing we do before we do anything within our big cat constructor or constructors is we're in the cat constructor. And the second thing we do is we're in the big cat constructor. So I'm gonna go ahead and let's say I want to print out some information. In big cat constructor number 2. First thing we'll see here is it's giving me an error. And the reason it's doing that is because when you call chained constructors like this, the invocation of this or super needs to be the very first thing that you do. And this is no different for super. If, for example, I want to call the superclass implementation of a different constructor, I have to do that on the first line. So this compiles, but this does not. I'm going to go ahead and delete a few of these things here, because I want to demonstrate this last point with a little less code. So last thing I want to demonstrate with constructors is an interesting concept when it comes to default constructors versus non-default constructors. So a default constructor is one that contains no arguments, or it can be one that you have with no arguments and then it has some implementation in it. Either way, Java will compile just fine in those situations. But if my cat constructor contains now a weight, and I'm going to go ahead and say this.weight equals weight. If I'm now in here, now I've got an issue. We can see here that IntelliJ is saying there's no default constructor available for cat. So before it knew which constructor to call, but now it doesn't. So what you have to do is, again, on the first line of the constructor, you have to use the super keyword. And now you need to give it the parameters that are required in order to actually construct the cat object. So in this case, I'm going to go ahead and give it a value of 10. And it looks like I still need to clean this up here. And then I'm going to remove that. Okay, so now if I run this code, now we get what we expect again. Within our big cat, we are calling our base class implementation, which sets the weight of our cat to 10 pounds. Now this is another little gotcha. Let's say I want to use weight. If you think about that, that's a bit of a circular reference because I'm trying to pass in the weight here before super is even constructed, and Java will catch that. If I highlight over here, it says you can't reference the weight before the super type constructor has been called. So Java's catching those sorts of smart programming errors that could bite you if you're not careful. Thanks, Java. All right, and that was the super keyword within a nutshell. As you can see, there are a few gotchas with using it, and it's important to understand the this keyword as well to kind of understand how super works. I really enjoy making this sort of content. If you're enjoying it, those likes really help tell me that you're enjoying it. Also, feel free to drop a comment if you're interested in me covering a certain type of video that I haven't already, or if you have any questions on what I did cover, or if you think I messed something up, I'd love to hear any feedback you have for me. Thank you all for watching. I hope you have a great rest of your day, and I'll see you next time. Take care.